yeah, the C parts, we have the W is a Dex function, xy over z. X is r plus theta, y is r minus theta, and z is theta squared. We need to find W del r. We need to find del W del theta. So let's quickly draw the tree diagram. Let's draw the diagram. The W is a function of three variables, x, y, z. Each of those variables, they are functions of what? R and theta. Del W del R is going to be, I'm going to be using subscript x, W, subscript y, W, subscript z. Okay, which is del W del x, del W del y, del W del z. So anywhere I see my W now, I'm going to use F. I'm going to be using F. Okay, so it's going to be del F del x times del x over del R. Okay, then plus del F del y. You differentiate this function with respect to y, and then where you stop here times del y over what you have here, del R. Then plus del F del z times del z R. Okay, come to this one later. So let's get the partial differential, which is what? Del W del x. So that one is going to give us what? Del F del x. This is the partial differential. You only differentiate the function while the other variables will be kept as constant. That will give you this. Then do the same thing also for del F del y. Don't forget del F is same as del W. Okay, respect to y. You only differentiate your y. You keep the other one constant. And that will give you what? That will give you this. Then del F del z. Differentiate. The best thing for us to do in this case is to rewrite this. Do the algebra, rewrite this in this form, and it becomes easy for you to differentiate. If you differentiate this one, the power will come to the front. You have this, and then the power minus 1 as minus 2. So that was giving us a minus xy over z squared. So that's that on that. Let's quickly get the other function. X is a function of r and theta. So we can get respect to r, which will be equal to what? This will be constant, that's 0. You only differentiate that one, that's 1. Do it again, respect to theta, that will be constant. You differentiate this one, that's what? That's plus 1. Then do your y also, respect to r, which is 1, respect to theta, which is what? Minus 1. Now begin to substitute now. Then you can also do this one. We don't have this one. Del z respect to r is 0. We don't have r function here. So we only have z respect to theta, which will give us 2 theta. If we differentiate this one respect to theta, we're going to have this. Final note, let's do this substitution. Del w del r. This one, del f del x. Then del x del r, that's 1, plus del f del y, which is this one, that's x over z, and then times del y del r. Del y del r is also 1, then plus the last one, del f del z is what? Is minus this, minus xy over z squared times del z del r. We don't have that, that's a 0. So it makes this place to be what? To be 0. So we only have this one, which will be equal to what? Which will be equal to y plus what? Plus x. Okay, that's what del w del. Then you can substitute for this You can tidy this one up. Your y is what? R minus theta. Your this one is r plus theta, or what, over z, that's theta squared. So this one and this one cancel. So you have 2r over what? Over theta squared. Okay? Then let's quickly get the del w del theta. The equation will be del f del x times del x del theta plus del f del y times del y del theta plus del f del z times del z del theta. Do your imputation for that. Del f del x, we have the value, that's y over z times x respect to theta, del x less theta, del theta, that's 1. This one is what? This one. Del y del theta, that's minus 1. Del f del z, we have this expression, is what? Times the z del theta, that's what? That's 2 theta. Okay? So if you do the algebra for this one, it's going to give us what? It's going to give us this. And that will be yz plus times minus, that's minus. So we have this. And then plus times minus, that's minus. That's a 2x. So that's what we have in this case. Okay? If we want to substitute, it's going to be cumbersome. It's going to be cumbersome. So we just leave it in that form. Okay? We can't, if you try to substitute, it's going to waste our time. Okay? Just leave it in that way. So that's the end of the C part. Okay? So please, if you're watching me for the first time, quickly smash the watermarks on this video and subscribe. Okay? At the same time, also click on like button and begin to type your comments. Make this section interactive. Finally, share the links of this video on all your social media platforms. Thank you for doing that. You can book your place for one-on-one or group discussion on either Calculus 1, Calculus 2, Calculus 3, Calculus 4, and or any other personal assistance. Thank you for doing that. The D part, show that del W del U plus del W del V equal to 0, where W is a function of this expression, U minus V, and what? V minus C. The first thing to do is to substitute for this expression. Let x be equal to what? U minus V, and y be equal to V minus U. Let's do that. So in that case now, we now have W as the functions of what? X, comma y. And your x now is the functions of what? The functions of U, V, y also is the functions of U, V also. What we are going to do now is the functions of x and y. And each of these functions are also functions of what? U and V. That means we can get del W, del U. We can get del W, del V. Okay? So let's go straight to the business. So this will be equal to what? Del W respect to U now, del U. So it's good, which is going to be what? Del F del x times del x, where you stop here, that's why you're going to continue on the top here, then U plus del F respect to the second function, del y times del y over what? Over U. So we've done it respect to the first function. Let's get the value for that. Then after that, we now do del W del V. So we don't have value for, there's no value for del F del x. There's no value for del F del y. But there is a value for del x del U. Okay? And if you differentiate this, the x respect to U, while you are keeping your V constant, it's going to give you 1. If you differentiate that same function respect to V, it's going to give you minus 1. while you are keeping your u constant. Quickly do that substitution. This one, that's 1. So I have here del f del x, then plus del y. Let's get the del y del u. Del y del u. If we differentiate this, del y del u, while you are keeping your b constant, is what? Is minus 1. So this one is minus 1. So this will change to minus. This will change to minus. So we have del f del y. Okay. So let's quickly get the next one. Let's get the next one. Del w del v. So in that case now, the equation, I want to maintain this place. The equation will be del w del v. That will be equal to del f. So in this case now, del x del v is equal to what? Del x del v is equal to minus 1. So I'm going to have here, I'm going to have minus del f del x. Y del v is 1. So that will give me, if you come back here and do your substitution, that will be what? Del f del what? Del y. So if you look at this now, you can see that this is like a mirror image. This reverse itself. This is positive here. This is negative here. This is negative here. This is positive here. So automatically, if you sum this together, what? 0. If you have it together, and that's that on this chain rule. Okay, we have made the previous videos on chain rule. Quickly go there now and watch it. And if you are watching it for the first time, please kindly smash the watermarks on the video and and click on the notification bell. Subscribe to the channel so that you can get notified anytime there's a new update. Please don't stop there. Click on like button and begin to type your comments. Make this section interactive. The links of this video on all your social media platforms. Thank you for doing that.